Hello guys, welcome to RR Digital. In today's session, I'm going to explain about HDFS model. So in Big Data Hadoop, this is the first model. Okay, so what is a HDFS here? So HDFS means basically Hadoop distributed distributed file system. So what is the meaning of this Hadoop distributed file system? So distributed means your data or your data files, it will distribute to different systems. So it will not store in a single system. It will distribute to different systems. So file means generally in big data Hadoop, your data it will store in a file format. Backend always it will store in a file format. So system means here our data generally it will store in hard disks or machines or nodes. Okay, so all these three same meaning only system or node or machine. Okay, so HDFS means Hadoop distributed file system. So in HDFS, now we'll discuss about Hadoop architecture. Okay, so first we'll discuss about Hadoop 1x architecture. Okay, so in a Hadoop 1x architecture, we have few drawbacks in Hadoop 1x architecture. Okay, so I will explain now what are the advantages in Hadoop 1x architecture and what are the disadvantages is there in Hadoop architecture, because initially when Apache Software Company released Big Data Hadoop in market, most of the companies they haven't used Big Data Hadoop technology because initial version, okay, in 1x version, few drawbacks they were found. That's why they didn't use the big data Hadoop technology. But in a later, they they released the upgraded version that is a Hadoop 2x. So what other drawbacks is there in 1x? All those drawbacks they resolved in Hadoop 2x version. After that, slowly most of the companies they started using this big data Hadoop technology. Okay, so now I will explain about Hadoop 1x architecture. Okay, so here I have one, you can assume here one user is there. Okay, so he is the user. You can just assume he is the user or I am the user. Maybe if I am trying to store my data, then I am the user. Or if you are trying to store the data, then you are the user. Okay, so now this user having some data file. Okay, some data file. Okay, so here maybe you can assume a data file name customer.txt. Okay, data file name is customer.txt. So this data file size you can assume 100 MB. This user having one data file, that data file name is customer.txt, and this data file size we are assuming 100 MB. Generally in the real time, data file size will get like GBs, terabytes or petabytes. But here, just for better understanding, I assumed data file size as 100 MB. Okay, so now this user want to store his data inside Hadoop. So how it will store that particular customer.txt file? Okay, so to store this data, so whom this particular user has to contact. Okay, so here I have one more node. Okay, I have one more node. That node name is name node. Okay, so here this is the name node. Okay, so what is the purpose of this name node? Why we need a name node? Okay, so here generally this name node it will work like manager for entire Hadoop architecture. So who is the manager for Hadoop architecture means name node is the manager for Hadoop architecture. Okay, so what it will do? So generally it will stores Metadata it will store. So where it will store? Is it will store inside hard disk or RAM memory? So it will always store metadata inside RAM memory. Okay. So what is metadata here? Okay. So generally metadata means here we have file, right, customer.txt. Okay. So that particular file name it will store. File size also it will store, and file is in which location, that particular location or path also it will store, and the user requested to store the data, so that particular username also it will store inside metadata. Also here which date that particular user requested to store the data, also timestamp. So exactly which hour and which minute, which second that particular data file stored. Okay. Not only this, here block id also it will store, and a block size also it will store. So what is block id and block size? For example, in our laptop generally will store our data, right? So where it will store? Inside hard disk it will store. So hard disk means a small chip, right? Okay. So that chip contains some storage capacity, whether 1 terabyte or 2 terabytes. Okay. So inside that chip, small blocks available. Each block having some storage capacity. Okay, whether that is a 64 MB or 1 GB, whatever. Okay, so that particular block ID also, that information also here it will store, and the block size also. Each block storage related capacity also it will store here. Okay, so all these generally will call metadata. Okay, metadata. So this information will call metadata. This metadata inside name node, inside RAM memory it will store. Okay, not in hard disk. So why it will store only in RAM memory, why not in a hard disk? Okay, generally this name node has to interact with multiple users in real time or live. Okay, because now one user requested, parallelly maybe n number of users will request, or n number of users will connect with the name node. So for each and every user parallelly, name node has to give response. So if parallelly in very fast it has to respond means compulsory name node has to store this metadata in the RAM memory. To read data from RAM or to read data from hard disk, which one will be more faster? Means only RAM memory. Data reading from where it will be fast means only if you read data from RAM memory, then only it will be fast. Hard disk means it will take time. Okay, so that's why here always name node they will use high-end configuration machines. Okay, because it has to interact with multiple users or multiple nodes same time. High-end more RAM also they will use here. More RAM is required because to store metadata. Okay, so this is about metadata and name node. Now this particular user will connect name node. Okay, hi name node, I have one data file, I want to store my data, could you please allocate me some space so that I can store my data? Okay, now name node is received request from user. Okay, so in that situation compulsory name node has to give response back to user. Okay, so now what name node will do? Okay, so before going to response, we'll discuss about some other node. Okay, so here I am assuming I have some data nodes, some data nodes. Okay, maybe I have 3 data nodes. Okay, in real time maybe a number of data nodes or thousands of data nodes or thousands of systems or thousands of machines. Okay, so first one I'm just calling as uh, data node 1, and second node I'm just calling as data node And the third one I'm calling as a data node 3. Okay, so now I have total 3 data nodes. Okay, so what is the purpose of this data nodes? Okay, your actual data, so your customer.txt file contains some data, some content, or maybe some data. Okay, so that the entire data and the entire content where exactly it will store means inside data nodes. Only data nodes having a storage capability, name node having only metadata storage capacity. Okay, but the actual data always it will store inside data nodes. Okay, so in real time n number of data nodes they will use based on a project requirement. Okay, so each data node capacity may be 1 terabyte or 10 terabytes. Okay, that is based on requirement. Okay, so now here each data node contains again some blocks. Okay, because each block it will store some piece of data. Okay, here I am assuming total 3 blocks available in each data node. Okay, so even my data node 2 also 3 blocks, and also data node 3 also 3 blocks. Okay, so here first one I'm treating as B1 block, and the second one I'm treating as B2 block, and the third one I'm treating as B3 block. Okay, so same way here also uh, B1 block, and here also B2 block, and here also B3 block. So like that, if you have n number of missions, each mission n number of blocks. Okay, in real time n number of blocks. But here I am just assuming each data node I have only 3 blocks. Okay, now you can assume this is completely new cluster. This cluster, all the data nodes and all the blocks, completely space is free. Completely entire space is free. Now who is having this information? Okay, so which data node contains space is free and which data node completely occupied. So that particular information only name node should contains. Okay, so what other data nodes is full, what other data nodes is space is available, that information only name node having, because name node is the manager for entire Hadoop architecture. Okay, now this name node has to give response back to user, right? Because user requested for storing the data, so name node has to allocate some blocks. Okay, so here just I'm assuming. So randomly, generally name node will pick up data nodes and blocks. Okay, randomly it will pick up. So here data node 1, it is assigned B1 block. Data node 1, B1 block, it is assigned. So here 64 MB data we can store, and again we can assume randomly data node 3. Here maybe you can assume B3 block assigned, and 36 MB we have to store. Okay, so name node now giving a response back to user. Okay, for you I assign total 2 blocks. Okay, how many blocks? Total 2 blocks. One block inside data node 1 B1 block, and another block that is inside data node 3. So you can go and you can store your data like that. Name node given response back to user. Okay, and here maybe few people they will get confused, why 64 MB in B1 block and 36 MB in a different block. Okay, Hadoop 1x architecture, each block default storage size 64 MB. Each block default storage size 64 MB. That's why NameNode allocated 2 blocks, because this data file 100 MB. So for to store 100 MB data, how many blocks is required? 2 blocks required. In real time, not 100 MB, terabytes. Okay, if it is terabyte means n number of nodes and n number of blocks it will assign. Okay, so now what user will do, because user got response. Okay, so here I have I have one more node that is called a job tracker. Okay, job tracker. So what is the purpose of job tracker here? Okay, so generally job tracker having a processing capabilities. Okay, so in entire Hadoop architecture, who is having a processing capabilities means only job tracker having a processing capabilities. That's why when you want to store your data, you have to contact job tracker. Again, whenever you want to retrieve your data, compulsory you have to contact the job tracker. So via job tracker only we have to read our data or we have to store our data. Okay, now this particular user will contact job tracker. Okay, hi job tracker, for me name node assigned so and so a data nodes and so on so blocks, could you please help me to store my data? So this is the request got from user. Okay, now what job tracker will do? So job tracker again it will contact the name node. Okay, hi name node, so and so user requesting me to uh, process data, so could you please let me know, can I proceed or can I wait? Okay, so based on that, here again NameNode will give a response back to a job tracker. Okay, you can proceed whatever user requested, that is correct. Then now what job tracker will do? Okay, so here now job tracker will split your data file. So who will split your data file means only job tracker. So Hadoop framework will split your data file. Okay, so your data file name is customer.txt. Inside that some content is there, but here it will split. Okay, so split to one 64 MB data it will. So 60 first split 64 MB data, split to two remaining data 36 MB. Okay, if it is 200 MB means how many splits? Four splits. So by default NameNode will assign four blocks because each block storage capacity 64 MB. Okay, so these split one split two. Okay, now it has to process. Okay, so before discussing about the processing concept, here I have one task tracker. Okay, so generally each and every data node contains one task tracker. Each and every data node contains a task tracker. Okay, so what is the purpose of this task tracker? Okay, what is the purpose of this task tracker? Okay, so generally task tracker, whatever job tracker will assign work to task tracker, that task tracker it will execute and it has to complete that work, and again it has to give response back to job tracker. Like for example, you can treat job tracker is the a lead for task tracker. And generally in real time what we'll do in software companies, okay, so lead will assign some work to developers, right? Okay. Again, end of the day or maybe next day status call, all the developers they have to give status update like that particular task is completed or it is in progress or he is unable to do. Okay, this kind of progress developer has to give lead, right? Okay, so here also same. Job tracker will assign tasks to the task tracker. Task tracker has to complete that work and then again it has to give progress report back to job tracker. Okay, if it is successfully completed, then successful information it will send. If it is failed, failure information it will fast, and it will in progress means in progress information it will send to a job tracker. Okay, so this is about the task tracker. So task tracker is not separate node. Data node, each data node is separate nodes. Each data node contains task trackers. So task tracker is a small kind of Java process. Okay, inside that machine itself one small process will run, that is called a task tracker. Okay, now this job tracker parallelly split one, it will send to data node 1, and split two related data it will send to this task tracker, because here nodes, so inside data node 1 data node 3 only it is allocated, so parallelly distributed. So your data file is very large also, terabytes petabytes also. Hadoop framework it will split into small chunks. Those n number of chunks or n number of small files parallelly it will distribute to multiple systems. So parallelly it will execute all your data files and it will store inside Hadoop. Okay, so here also job tracker first split it sent to task tracker and second split it sent to another task tracker. Okay, so inside data node 1 b1 block it is assigned, right? So here half of the data 64 MB it will store here, and remaining 36 MB inside b3 block data node 3, right? So here 36 MB it will store. So parallelly, both the task trackers will execute and it will store the data inside the task trackers. Okay. Now, okay, sir, you said each block size 64 MB, but here you stored only 36 MB. What about the remaining space? Okay. In a Hadoop 1x architecture, once you store some data, it is less than 64 MB like 30 MB or 40 MB. Once you store some data file, remaining space completely it will be waste. It is not possible to store another data file in same block. So this is one a drawback in Hadoop 1x architecture. Okay, so remaining space completely it will be waste. So your block size is 64 MB, but you stored 1 MB data file. So that means remaining 63 MB it will be waste. Okay, so this is drawback in 1x architecture, but 2x in 2x they resolved that issue. Maybe in later sessions I will give a more explanation about the Hadoop 2x architecture. I will explain the remaining architecture in the next sessions. Thanks for watching this video. Bye bye.